Hello, grade 11s. This is question 4 of the past paper, the June 2022 past paper, which is actually an exemplar. It's not the actual paper they wrote, it's just an exemplar, a sort of, this is how the exam is going to look like type of thing, right? I hope you guys can understand me. So yeah, I'm solving it. If you didn't see question 1 up to 3, check the description of this video. Yes, I hope I'm clear. Description of this video, you're going to see all the questions from question 1 up to the end, right? Even question 5, you're going to find it in this specific description of this video. Question 5, 6, and 7, all the way up to the end. Just check the description, you'll find it. Anyways, let's solve this problem. We are dealing with linear patterns, right? Hope I'm pronouncing it correctly, linear patterns, right? Anyways, let's solve this problem. So what you're given here is we are given this linear pattern, right? And in 4.1, we asked to find the value of p. So you know linear pattern. What is unique about linear patterns is that it has a common difference, right? It is a common difference. So that's how we're going to find p. So this is term number 1, term number 2, term number 3. So the common difference is d, right? Is equals to term number 2 minus term number 1 is equal to term number 3 minus term number 2. So such problems, you're going to do them in grade 12, by the way, so you better know them now. Like this type of problems, they're there in grade 12. You can open a textbook in grade 12, you find them. So term number 2, we have 2p minus 3, so it's 2p minus 3. We're just going to put it in brackets just to separate it. And in term number 1, we have 1 minus p, so it's 1 minus p, right? It's equals to, term number 3 is p plus 5, right? Put it in brackets, minus term number 2, which is 2p minus 3. So we're just going to equate these and just solve. So we're going to have 2p minus 3 minus, so this minus will multiply everything that it's in here. So it's minus 1 plus p is equals to p plus 5 minus 2p plus 3. This is what happened, multiply everything here, right? So this is an equal sign, by the way. So what's going to happen is this p will go away with this p. I mean, if you transpose either or, it's just going to be minus, right? And then I'm going to transpose this p to the other side. We have 2p plus 2p. And then here it's just going to be minus 4 is equals to, this and this is 8, so it's 8, right? And then I'm transposing this minus 4 to the other side. I have 4p is equals to 4 plus 8 is 12, right? And then divide by 4 both sides. P is equals to 3. So this is 4. P is equals to 3. I hope you guys found P is equals to 3. If you didn't, let me know in the comment section. What did you find? So now we go to 4.2. I hope you guys can hear me. I tend to speak. I tend to lower the volume of myself. So write down the value of, so 4.2.1, the first term of the pattern. The value, the actual value of the first term of the pattern. First term is T1, right? And it's equals to 1 minus P. But we found P to be equals to 3 in the previous question. So we're just going to say 1 minus 3, which is equals to minus 2. So this is the first term. First term is minus 2. That's why it's 1 mark. I mean, there's nothing much we did here. So 4.2.2, the common difference. Remember the common difference? I said d is equals to t2 minus t1 is equals to t3 minus t2. So you can take any. You can take this part here, or you can take this part here. It's up to you. So the common difference, d is equals to, what's term number 2? It's this one here, 2p minus 3. Put it in brackets. Minus term number 1 is 1 minus p, right? So it's equals to 2p minus 3 minus 1 plus p. D is equals to 3p minus 4. But what is p? It's 3. So it's 3 into 3 minus 4. 3 times 3 is 9. 9 minus 4 is 5. So d is equals to 5. I hope you guys got the same thing. D is equals to 5. So yeah, we're just going to do the last part of the question. I mean, this one, I'm sure it was easy, guys, right? We're collecting all the 7 marks. It was really easy and interesting. Explain why none of the numbers in these linear patterns are perfect squares. Okay, now they are trying to be tricky with us. They don't want us to get all the marks. they're asking us these type of questions. I'm sure you guys are saying that, right? Anyways, let's substitute here. Instead of writing p, you're gonna write 3. Where does p would put 3? Where does 3 put p? Right. So let's do that. So you have 1 minus p. You have 2p minus 3. We have p plus 5. So 1 minus our p is 3, right? So I'm just gonna 3. You have 2 into 3 minus 3. We have 3 plus 5. Right. So here we're just gonna have minus 4. What is it? Minus 2. Sorry, why am I saying minus 4? Jeez, it's minus 2. And here it's 6 minus 3 and 8, right? So it continues like that. So it's minus 2, 3, and 8, right? And then it continues like that. You're gonna get 13, you're gonna get 18. It just continues. These are added numbers, by the way. But this is what we have, right? So if you look at all these numbers that I'm putting in this box here, all of them except 2 end with either 3 or 8, right? They end with 3 or 8, except this one. They end with 3 or 8. This is 3, this is 8, this is 3, this is 8. You see, that's what's common here. They end with 3 or 8. And then if you had perfect squares, so here you're literally trying to convince the marker on what you are talking about, right? You'll definitely get marks up to this stage. You'll get probably a mark because this is 2 marks. So perfect squares, if you had, let's say you had 0, you had 1, you had 4, you had 5, you had 6, you had 9, it's a perfect square because here it ends with 0. It can be 100, by the way. Here it ends with 1. It can be 121, right? 121, square root of 121 is 11. Here it can be 144. I'm just literally taking in numbers. Here it can be 25, right? The square root of 25 is 5. Here it can be 36, right? Here it can be what? It can be 169, which is 13, right? So that's basically what you say here. They say explain why none of the numbers in these linear patterns are perfect squares. They are not perfect squares because these are the perfect squares. I mean, these give you perfect squares, right? These numbers at the end give you a perfect square. These numbers at the end give you a perfect square. I hope you get what I'm saying. I mean, I don't know any number where it's a root of, I don't know, 28 and it's a perfect square. I don't remember. Or a 3, like there's nothing, 23. Or root of 43. I hope you get what I mean. Root of 53. There's no number where I put a square root and a number that ends with these numbers that are here. It will give me a perfect square. Hope that makes sense. If it didn't, you know what to do. You know the drill. Ask. I know you guys always like to use English in some way. This internet thing. Now I'm saying ask. Ask in the comment section. Just ask me. Ask. Yo, no, these things are bad. Anyways, let me know in the comment section below on whatever that you guys didn't understand in this question. Don't be shy. We obviously take time to understand these things, so no pressure. Thank you so much for watching. If you haven't subscribed, please do subscribe. If you want other questions, as I said earlier, check the description of this video. You will find all the questions from question 1 up to the end of this specific past paper. Right? If you need anything else, let me know in the comment section. I'm here to help you. Otherwise, thank you so much for watching. Please do subscribe. Don't forget that. I really appreciate it, and like this video if you really enjoyed it. Thank you so much. Take care.